All right, so now that we're kind of primed for confidence intervals, let's define a confidence interval. So in short, a confidence interval is a point estimate plus or minus a margin of error. So an example is that if we had a confidence interval for a population mean, we would have the sample mean as the point estimate plus and minus error. Now you could take this, well, we'll get into it here in a minute, but you could write this in interval notation as something like this. So point estimate minus error, point estimate plus error. And the minus the error would give you a lower number, and adding error would give you a higher number. And so this gives you a range of numbers that constitutes your confidence interval. Um, so a confidence interval is defined by the confidence level that one wants or that one designs. An interval is a range of numbers, so a range of numbers between like 85 and 97. So for example, if a student decides on a 90% confidence level, then the student knows the confidence level procedure has a 90% probability of producing an interval containing the true population mean. Confidence intervals can be written in the following three forms. So one form is a point estimate plus and minus the error. That's what I kind of drew up here earlier. The other form is that it can be written as, left and right parentheses with a point estimate minus the error, comma, point estimate plus error, right parentheses. And then the third way is to have the population parameter in the middle and say that it's greater than the point estimate minus error and less than the point estimate plus error, which is kind of what's given up here. So there's three different ways that you could express a range of numbers, that you could express a confidence interval. And that's kind of the short of it all. At length, to maybe help you understand, what a confidence interval is, I kind of given an analogy. So imagine an analogy with a bullseye, archery target, and arrows. The center of the bullseye is the population parameter. So let's say you're trying to determine what the population mean is. You're trying to determine what the population mean is. That's the center of the target. The arrow itself is a random sample from the population. So you take a sample from the population. The point of the arrowhead is the point estimate. So from this sample, you calculate a sample mean. Sorry for that moving around there. So from this sample, you calculate a sample mean. Okay, the point of the arrowhead is the point estimate of the confidence interval. So if you imagine you've got the point of the arrow is the sample mean, then the width of the barbs here would be the error being added and the error being subtracted. The circular radius around the point is equal to the margin of error with a 90% confidence level. And so with a 90% confidence level, what that means is 9 arrows out of 10 will land close enough to the center to include it. So kind of what I've drawn down below is here we have uh, the mean of sample one, and it's at the center. And then if you had plus error and minus error, that kind of creates this circle. And you can see this interval around the sample mean includes our population mean. So there's a 90% chance that the confidence interval that you made actually includes the population mean. That means there's a 1 out of 10 chance that the confidence interval that you make does not include the population mean here. It's outside of it. So if you're trying to estimate a population mean and you want to give a range of numbers that the population mean will be within, um, you can say it without 100% certainty, but you could say it with a 95% probability that the interval you've created contains the population mean. Okay, let's take a look here at a small example. So construct a confidence interval from the given information. Suppose we have collected data from a sample. We know the sample mean is 7, but we do not know the mean for the entire population. Given the desired confidence level is 95%, the error bound for the mean is 2.5. Construct a confidence interval. All right, so this is what we need to create. So what we need is we need a confidence interval. So we need a point estimate minus error, and we need the point estimate plus error. So let's see, what were we given? Well, we were told that the sample mean is 7. So that gives us a part of what we need. Okay, but we don't know the mean for the entire population. We're trying to figure that out. Given the desired confidence level is 95%, the error bound for the mean is 2.5. So the error bound for the mean is 2.5. So this error bound for the mean being equal to 2.5, that's the value of the error that we need there and there. So let's go ahead and plug this in, because now we have everything we need for our confidence interval. So we're going to put a 7 minus our error, which is 2.5, comma, our sample mean, which was 7, plus the error, which is 2.5. And let's see, 7 minus 2.5 is going to be 4.5. And 7 plus 2.5 is 9.5. So this is our 95% confidence level for the population mean. Okay. So I think right now, let's see here. Yeah, I think right now this is a good place to stop. Let me know if you have any questions.